Welcome to the Great Summer Math Mix-Up 2024. Time to do a summer speed trap and have fun doing math outside. You need basic supplies for this. You'll need a stopwatch, paper, pencil, a measuring tool like a tape measure. Here's what we're going to do. Decide what you want to find the speed of. I'm going to share some ideas later. Gather your supplies. Measure the distance of where you're going to time. For the most accurate results, you'll want 2 people to work on timing. We'll talk about it later. Have fun timing your activity and then calculate the speed. We decided to find the speed of the cars going down our street and the people going down the slip and slide. You could do kids running, kids on bikes, kids going down a regular slide, a dog running, remote control cars, swimmer, kids on scooters.
Let's go over the setup for our speed trap on our street. Here's a picture of our street. We had 2 people set up. We had 1 person here, and their job is to pay attention to when a car passes their line of sight. And then we had another person over here, and their job was to pay attention to when a car passed their line of sight. It didn't matter which direction our cars were going, but we did pay attention to, there's this curve on our street. We did pay attention to if the cars were coming out of the curve or into the curve, and if they were going faster or slower. It was really interesting to do. So we set our 2 people up, and then we measured the distance between them. So you need to know this distance. And then as a car would come by, the person that it was passing first, so let's say our car was right here, then the person that is watching that side would start the clock, and the other person at the other end would just put their hand down or say stop as soon as the car passed their line of vision. This was trying to give us the most accurate times for each of our cars that went by.
We chose to do a pretty far distance on our street, and in order to measure it, we just measured the length of 2 sidewalk squares and then counted how many squares we had and multiplied it by that number. Let's start timing those cars.
Speed. We've all seen speed limit signs when we've been driving around, walking around, and this week we decided to do a speed trap. Now, my husband thinks that every car that drives down our street is going too fast. And sometimes I agree with him, and sometimes I think he's not right. So we decided for our summer math mix-up week number 2, we were going to do a speed trap on our slip and slide and on the cars driving down our street. So let's start by talking about what is speed. Speed is, simply put, when we think about our speed limit, we would say it's 25 miles per hour. So speed is a distance, that's our miles. Per means a ratio of or divided by our time. So 25 miles per hour is like 25 miles per is our fraction line, hour. So we're going 25 miles per hour. That's the speed limit on the street that we did our speed trap on. So let's do some math and figure out how fast or slow the cars were going down our road. Here's our paper, our lovely recording of the cars that were going down our neighborhood street with a 25 mile per hour speed limit. As you can see, as we were recording our times between 2 distances, we had time to doodle. And there's a sharp curve right by where we were recording our speed. So the arrows are indicating if they were coming into the curve or coming out of it. And I would say that coming out of it, that's all of these arrows. It's a little bit, they were going a little bit faster. So anything going this way was coming out of it. And it does look like it's generally a little bit faster. All right, so let's talk about how we measured. I mean, our times are great, but what was our distance? So we had a spot, here's our road, and we had somebody here, and we had somebody over here, and we measured the distance between us. So this distance was 126 feet. And this was helping us, so we had a good line of sight. So we were looking straight ahead and marking when a car passed either of our line of sights, and we're timing between these 2 yellow dots. That's how we were doing our speed trap. So all of these times right here are between these two yellow hashtags, 126 feet. It took 6.22 seconds, or 4.12, 4.32. Okay, so what's important here is we know that the distance between our two spots was 126 feet, and we know that our time was in seconds. We were just using our stopwatch on our phone. So let's take this first one, 6.22 seconds, which, by the way, as we were timing this car, I kept thinking, this car is going so slow. So I'll be really interested to see what their speed was. It was a cute old couple just taking their time going through the neighborhood, which I appreciate. Okay, so we're going to start with, we had 126 feet, and the time was 6.22 seconds. We'll start by setting this up into our speed ratio. So speed is distance divided by time. Our speed in this case was our 126 feet divided by 6.22 seconds. Now, it's really important that we keep our units on here. We're going to do a quick review. You might remember this from algebra or chemistry when you were doing units. But we want to eventually convert into miles per hour. So let's start by doing our seconds to an hour. So we can say how many seconds are in 1 minute. And what I like to think of is I have seconds in my denominator. That means I need seconds in my numerator. And that means my minute is going to stay in my denominator. Also, our end unit of an hour will need to be in our denominator. And we can continue working that way over. So we have how many seconds in a minute? We have 60 seconds in 1 minute. And then we're going to do another conversion factor. This time we're going to say how many minutes are in 1 hour, because we want to end up with hours in our denominator. And there's 60 minutes in 1 hour. Let's get our feet converted to miles. So we need to know our conversion from feet to miles. And I happen to know this from a song that my dad used to play when I was little. It just always got stuck in my head. So we have right now feet in our numerator. We need that unit to cancel, and we want miles in our denominator, because remember, we're trying to find miles per hour. We have our hour in our denominator, so we want our miles in our numerator, our feet to cancel. And we know that there's 5,280 feet in 1 mile. We know that, I know that from a song from my childhood. You can look this up. And also, depending on the skill and age of the kids that you're working with, you might just use Google to convert this, which would do it in one quick tap. So, all right, let's double check everything. I'm going to go through and make sure that all of my units are going to cancel correctly. So I have a second on my denominator and a second on my numerator. They cancel out to a 1, which I'm not going to write. I sometimes call it a giant 1. There's a minute and a minute that cancels. And then clear at the beginning and clear at the end, we have a foot on top and a foot on bottom. So now we have a lot of numbers and a mile and an hour. So let's grab our calculator. I'm going to use Desmos. If you haven't used Desmos scientific calculator, or graphing calculator for that matter, it is a great tool. Way better than having your child use their phone, because it's not as distracting, and free. So I'm at Desmos Scientific Calculator, and I'm just going to set up a fraction with the fraction button, a divided by b, and then I'm going to multiply. So 126 times 60 times 60 times 1, even though we know that 1 doesn't change anything with the identity. 6.22 times 1 times 1 times 5280. So we have typed in our entire answer, and our calculator tells us that the speed of the car that we got on that first clock that I thought was going so slow was 13.8 miles per hour, and that is slow. So this speed was 13.8 miles per hour. It was really lovely sitting there watching them drive by, as I have 2 little kids, and it was slow, and it was 13.8 miles per hour. Let's do a couple more calculations, and now that we have our conversion factor, actually, we can just use the calculator that I already have up with Desmos. So we have, the next one was 4.12, and it felt like a normal speed to me, but let's just do that math really fast. So in our speed equation, the only thing that's actually changing is the time. So our speed was 126 feet, and this time it was 4.12 seconds. Now I'm going to just copy all my conversions. So I had 60 times 60 times 1. This was a second, a minute, a mile, 5,280 feet, 1 hour, and 1 minute. Okay, so checking our conversions, the units, second and second, minute and minute, and then foot, feet and feet cancel. So I'm going to go into decimals. And actually what's really nice about decimals, you can hit enter and it saves that equation, and I can copy it. And all I need to change on these now to get these really fast is the bottom. So 4.12, 20.85 miles per hour. I'm going to just call that 20.9 miles per hour. Still not even going to speed limit. How lovely. Okay, let's do some quick calculations and get our fastest time was 3.10. Let's see what 3.10 is. So all I have to do is change my time right here. 27.7. I knew they were speeding. Okay, what's really funny about this is my husband is sure we need a speed bump on our street, and I am too, honestly. We did this during the middle of the day, and I feel like in the evening, cars are going a lot faster. But it looks like our fastest speed was 27.7 miles per hour, and our slowest speed was 13.8. This one was a 13.8 miles per hour. And that's quite a range. I would say the average, it looks like, is pretty close to 4.5 or 5 seconds. Let's do how fast that is real quickly. So we had 126 times 3,600. That's 60 times 60 divided by 5,280. Answer divided by, let's say 5. 17 miles per hour was about average. That's kind of wild to me because it seems like they're going so fast. So the average speed on our street on this Friday afternoon when we were doing this was probably about 17 or 18 miles per hour.
Next, we tried to set records on the slip and slide. The slip and slide was the absolute best time. We disregarded the height and weight recommendations for this slide, and glad we did because everybody had a blast.
I'm going to just pick a couple of these and calculate the speed of how fast we were going down our slip and slide today. So our slip and slide was from Costco. My mom bought it. She spoils the grandkids. Was 30 feet long. And then our times are in seconds. So let's figure out our speed. For our first one that we timed was a 1.97 second run. So our speed is distance divided by time. So our distance was 30 feet divided by our time was 1.97 seconds. We're going to go through our conversions again. We want to convert from seconds to hours because we wanted to know how fast we were going in miles per hour. And we want to convert feet to miles. So I start with there are 60 seconds in 1 minute. That's going to cancel or divide out our seconds. And then there are 60 minutes in 1 hour. And then for miles to feet, there are 5,280 feet in 1 mile. So we have our conversions written out. We check all of our units cancel correctly. So we have a second divided by a second, minute divided by a minute, and then a foot divided by a foot. So let's grab our calculators and figure this out. The Decimal Scientific Calculator is one of my absolute favorites for kids to be using at home instead of a phone. So much less distracting. If you need some help using it, I'll be happy to help you. But I'm just going to set up a fraction and type out my multiplication on the top. So 30 times 60 times 60 times 1. And then on the bottom, we have 1.97 times 1 times 1 times 5,280. Of course, you can leave the ones out, but I'm just putting it in to show. Oh my gosh, let's round up, 10.4 miles per hour. That first run that we timed was 10.4 miles per hour. That's wild. We were trying to beat 1.70. So much fun. The adults were doing this. The kids were doing this. It was so much fun. So 1.70 seconds was our fastest time. So our speed is distance, 30 feet, divided by 1.70. So we have seconds. 3,600 seconds in 1 hour. And 1 mile is 5,280 feet. Let's check this one out. Okay, so we're doing 1.7. 12 miles per hour. That just blows my mind on our slip and slide. We were having an absolute blast. Okay, let's just do a quick wrap up on this. So for speed, it is distance divided by time.